Welcome to this tutorial on creating a 3D parkour game using Java. In this series, we will design and develop a fully functional parkour game with an immersive experience. Before we start coding, let's discuss the tools we'll be using. We'll be using Java along with the JavaFX library for our 3D graphics. Ensure you have Java JDK and an IDE like IntelliJ or Eclipse installed. Additionally, download the JavaFX SDK and configure it in your IDE. Let's create a new project. Open your IDE, create a new Java project, and name it 3D Parkour Game. We will start by setting up the basic structure of our game. First, we need to create our main application class. This class will extend the application class from JavaFX. Let's create a class called GameApp. Here's a breakdown of the code. We import necessary JavaFX classes, create our main application class, set the title of the window, and launch the application. Next, we need to set up a 3D environment. We'll create a simple 3D scene and add a camera that will give the player a view of the game world. Let's add a perspective camera to our scene. In this snippet, we create a perspective camera, position it back from the scene using the setTranslateZ method, and set it as the scene's camera. Now our 3D scene is ready to be viewed. Next, let's create the ground and several obstacles that the player can jump over. We'll represent the ground and obstacles with simple boxes for now. Here, we created a brown box to represent the ground and a red box for an obstacle, positioning them accordingly in the scene. This forms the basic level of our parkour game. Let's add player controls. We want the player to be able to jump and move around. We'll be using event listeners to manage key presses. In this piece of code, we're adding an event listener for key presses. We check if the spacebar is pressed to handle jumps and W for moving forward. In a real game, these events would be linked to actual player movement logic. Now let's implement our player character. We will represent our player as a simple box for the initial version. Next, we will add movement logic. Here, we created a blue box representing the player and set its initial position. The move logic allows the player to move forward and backward in the scene using W and S keys respectively. Next, let's handle jumping mechanics. When the player presses the spacebar, we will move the player upward momentarily. This is a very rudimentary jump implementation. For better physics, we would need to incorporate real gravity and jumping dynamics. Now, let's add a game loop to constantly check for player state and update the scene. A game loop is crucial for continuously processing input, updating game entities, and rendering. In the game loop, we will add logic to handle player movements, collision detection, and any ongoing mechanics like jumping and falling. This will give us the necessary framework to build upon. Collision detection is vital for a parkour game to determine when the player has landed on the ground or hit an obstacle. We'll keep it simple for now with basic bounding box checks. In this code, if the player intersects with the obstacle, we'll trigger collision logic. This is a starting point for more sophisticated physics interactions. Next, we need to implement gravity for our player. We can achieve this by continuously checking the player's position and simulating gravity during our game loop. Here, we simulate gravity by constantly lowering the player's y-coordinate, ensuring the player never falls below the ground level. Now that we have basic movements, let's refine our jump logic and implement a full running and jumping feature. We introduced a jump velocity to control how high the player can jump. The is-on-ground boolean ensures the player can only jump when on the ground, giving a realistic parkour experience. Let's also add a scoring system to the game. For every obstacle jumped over, the player will earn points. We check the player's position relative to obstacles. Each time the player jumps over an obstacle, the score increases, and we can reposition the obstacle to maintain gameplay. Next, let's add visual effects and sounds for better player experience. We'll need to add background music and sound effects for jumping and scoring. With this code, we first import the media-related classes and load sound files. Sounds like jump and score notifications can be added to improve excitement in our parkour game. After adding sound, we can work on importing textured models instead of using basic shapes, like our player character and obstacles. This can be done using external libraries for JavaFX. This will enhance the aesthetic appeal, making our game more engaging. For now, we're using simple shapes, but later we can transition to 3D models. Next on our roadmap is implementing advanced enemy AI. We want to create dynamic obstacles that will chase the player or block their path. This can greatly enhance gameplay difficulty while keeping things entertaining for players. We can use simple pathfinding algorithms or NPC movement logic. Also, consider adding level transitions and difficulty scaling as the game progresses. Every few seconds, we can introduce new obstacles. It's always engaging for players to witness their skills being tested as levels progress. Giving them increasing challenges keeps them invested in the game. Finally, let's wrap up by discussing how to build and package your game. We want to create an easily distributable JR file. Simply use the export feature in your IDE to create a runnable JR file. This makes it easy for others to play your game without needing to set up a developer environment. Thanks for watching this extensive tutorial on creating a 3D parkour game in Java. I hope you learned a lot and feel empowered to continue developing your own game.